Hello, mathematicians. Today we are working on Lesson 12 of Module 4 in Eureka. This is going to be one of those lessons where I'm going to trust you to pause when you need to pause and to give yourself the feedback that you need to give and to do the thinking that I ask you to do. Your learning is up to you. It's your choice. Yesterday, we talked about factoring expressions. Today, we're going to continue with the distributive property, except we're going to be working on distributing those expressions. So first, we're going to start with this opening exercise, and I want you to create a model that shows 2 times 5. Now remember, when you read that, you should really be thinking 2 groups of 5. How would you show that as a model? Then do B, which is create a model to show 2 times B, or 2B. We know that those are the same things. When a number and a variable are juxtaposition, or side by side, it means we need to multiply. So again, you should read this as 2 groups of B. How would you draw those models? Please draw those models now, and then check back to see if you are correct. If you are back with me, it means you have your models created. So you should have something like this. 2 groups of 5 should look like this. 2 times 5 means 5 plus 5. So that would be my 2 groups of 5. When I do 2b, I don't know how big b is. You can make it as big as you want, but I know that I have 2 of them that are the same. That is 2 groups of b. So now we're going to move to example 1, where we're going to try to write an expression that is equivalent or the same as 2 groups of a plus b. So first, we're going to create a model that would represent a plus b. So go ahead and draw a model for a plus b. Again, it doesn't matter if your a is bigger than mine or smaller than mine. Just that A and B are different, so they should be different sizes, and that would be A plus B. So now the expression 2A plus B tells us that we have 2 of the A plus B's. So if we create a model that shows 2 groups of A plus B, it means we need to do 2 of these. So it would be A, B, A, B. That would be our what we did yesterday when we had 2 groups of A plus B. So how many A's and how many B's do you see in this diagram? Hopefully you said you see 2 A's and 2 B's. So how many A's? 2 A's. And how many B's? 2 B's. So now it says, how would the model look if we group together the A's and then group together the B's? So this is like that commutative property where we can switch the order of things and put them the way we want and still get the answer. So how would that look if I put my A's and B's together? It would look like this. Here's my A's. Here's my B's. So what expression could we write to represent this new diagram? Well, if I have 2 A's here and 2 groups of B here, this could look like 2A plus 2 B's. This expression is written in expanded form. We had this in our notes yesterday. This is the expanded form of this expression. The 2 groups of A plus B is called the factored form because we factored out this 2. So what we can figure out is what conclusion can we draw from the models about the equivalent expressions? We can decide if we have A, B, B, and then we have A, B, A. Sorry, my doesn't really set up exactly right. But what we see is that they're the exact same. So we could say that the factored form 2a plus b is the same or equivalent to the expanded form 2a plus 2b. So our target is to be able to write, using the distributive property, we can write these expressions either in the factored form or in the expanded form. We can go from the expanded form to factored form or from the factored form to the expanded form. This is going to be crucial when you get into higher levels of algebra. There will be different times where you'll want to distribute and different times you'll want to be able to factor. So we're really, again, building that foundation for algebra and setting that up so that we can use it later on in our math careers. So just to prove that these are the same, it's difficult to kind of visualize when we have letters. So let's go ahead and plug in numbers and see if we get the same thing. So let's let A equal 3 and B equal 4. So if we have two groups of A plus B, and anything I write, remember, you should be writing as well. If I substitute, that means I have two groups of 3 plus 4. Then if I use my order of operations, I need to do my parentheses first. So I have 7. I'm going to keep my parentheses around that number so that I can still use juxtaposition, but that my reader doesn't get confused and think that's 27. So those parentheses are super important to separate the numbers when I'm using juxtaposition with two numbers. So now I do 2 times 7, which equals 14. Now let's look at it as the expanded form of 2a plus 2b. Sorry, my camera keeps turning on me. So if I have two groups of 3 plus two groups of 4, 2 times 3 is 6 plus two groups of 4 is 8. 6 plus 8 is 14. So when we plug in the numbers, we can see that the factored form equals 14. The expanded form equals 14. Therefore, both of those expressions are equivalent. What would happen if we doubled A plus B? That means we double A and we double B, just like this. So this is double A plus B, or we have double of A and double of B. So now let's look at example 2. Write an expression that is equivalent to double 3x plus 4y. So this says, write an expression, sorry, darn my camera. Write an expression that is equivalent to double 3x plus 4y. Well, when we double something, it means we have two of them. So how can we rewrite double 3x plus 4y? We can write it as two groups of 3x plus 4y. So now it says, is this expression in factored form, expanded form, or neither? Remember yesterday we glued these handy notes into our math notebooks where we showed this is the expanded form of the distributive property and this is the factored form of the distributive property. So when I look at this, 2x, 3x plus 4y, does it look like this one or like this one? It looks like this one. I have the factor out of here. I have the factored version out here. So that is the factored form. So this would be factored form here. And you need to be able to recognize factored form and expanded form, and we'll be going back and forth between the two. So now it says, let's start this problem the same way that we started the first example. What should we do? Well, when I look back at my first example, the first thing I did was just did the a plus b. So in this case, let's go ahead and do the 3x plus 4y. So this would look like 3x plus 4y's. So now turning the page. How can we change the model now to show that it's two groups of 3x plus 4y? Well, that should be pretty simple. Since we know what one group of 3x plus 4y looks like, we should know what two groups of 3x plus 4y looks like. So if this is 3x, 4y is a little bit longer because it's four groups of them. Then here's another group of 3x and another group of 4y. So are there terms that we can combine in this example? Are there terms that are similar to each other? Yes. We could commute these around, use the commutative property to change the order of these so that we have our terms that are similar together. So what if I drew it like 3x and 3x? So it's these two things still, but instead of being separated, now they're together. And then I have one 4y and another 4y. Again, we know that we didn't change the value of this expression. We just changed the order of the terms, and we are allowed to do that because of that commutative property. So, are there terms that we can combine here? Yes, if I have 3 x's and 3 more x's, how many total x's do I have? If I have 3 groups and then 3 more groups, that means I have a total of 6 groups of x's. And then if I have 4 y's here and 4 more y's here, how many y's do I have? 8 y's. You can also think of it like this is our generic way to do 3x, but this is really x, 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 x. So how many x's are there? 1, 2, 3, 4, 5, 6. This is really 4 y's. 1, 2, 3, 4, 5, 6, 7, 8. So we have 6 x's and 8 y's. So what is the equivalent expression that we can use to represent those two groups of 3x's plus 4y's? We could use 6x plus 8y. So 6x plus 8y, this would be considered the expanded form. And it is equivalent or the same as two groups of 3x plus 4y. And this is known as the factored form. Now this says, summarize how you would solve the question without the model. Do you notice what I did here to get from two groups of 3x plus two groups of 4y to 6x and 8y? How can I get 6x's here from this situation? Well, hopefully you remember the distributive property means to pass out groups of. So what I'm really doing here is I'm passing out two groups of 3x and two groups of 4y. So if I was ready to move beyond the models and I didn't have to see them, I could see that I know I have two groups of 3x, which would really be 6x's. And I have two groups of 4y's, which means I really have 8 y's. So I have 6 x's and 8 y's. So when there is a number outside of the parentheses, I would multiply it by all terms on the inside. So remember, we don't want to be, if we're a Pepsi distributor, we have to go to Price Chopper and Hy-Vee. You can't just go to one or the other because the other store will be mad and they need their Pepsi products as well. So you need to make sure you go to both places.